Miss West. So we are doing another video on Chapter 5, Lesson 8. We are not doing a song today, and the reason being is because I wanted to show off my new couch. I just thought you guys would want to see that because I'm super pumped about it, so that's exciting, right? All right, let's go ahead and get started. We are doing Chapter 5, Lesson 8, which is on factoring. Our learning goal is that students will be able to simplify algebraic expressions using like terms. That like terms means a lot with this. We're going to be thinking about like terms the entire time we are factoring. Okay, that's the main part of it. All right, take your time. Pause this video at any time that you need to. Slow things down or just take a break. Let's go ahead and get started. Okay, so remember, think about the numbers or variables that they have in common and take them out. Okay, we'll talk about more about taking them out, and I'm not talking about to dinner or anything like that. We are taking them out of the equation, okay? It'll become a little more clear the more problems we do together, okay? But think about the things that they have in common, and we're taking them out, all right? Make sure to write everything that is typed or written in these videos down before moving on with us. All right, so this is on page 418 in your books. Sorry, I thought I had to sneeze. Find the GCF of each pair of monomials. So we are taking 32x and we are taking 18, and we want to find the greatest common factor, the greatest things that they have in common. How I do that is called the birthday method. Okay, I put both of the numbers or variables, what have you, the two things that we are finding the GCF of, and I am going to draw a little L shape, okay, up underneath them. All right, and I am going to think about a number or variable that goes into both of them, okay? So the easiest thing here is that I can look and see these are both even numbers. And even numbers I know automatically, and most of you do, that 2 can go into both of the even numbers. So if I know that 2 goes into 32x and 2 goes into 18, I'm going to go ahead and take my 2 out. Now the number that goes underneath is what you can multiply by 2 to get 32x. It's kind of like the opposite of a division problem. So 2 times what gives me 32x? Well, 2 times 16x gives me 32x, and 2 times 9 gives me 18. Okay, so now we do another layer to our birthday cake. We need to think about what number goes into both 16x and 9. So I'm thinking. Okay, nothing else goes into those except for 1. Whenever you take out 1, and that's the only number you can take out, that's when you're done, okay? So our GCF of 32x and 18 is 2. Now here's why. We are going to take the numbers that are on this side and multiply them together. 2 times 1 gives us 2, so our GCF is 2. Okay? And that's our answer for that problem. So, now let's move on to the next problem. Okay? We've got 27s and 54st. Hopefully you can distinguish my S's from my 5s because they look a little similar. All right, so I can see that you know your 9s pretty well. Some of you do and some of you do not. But if you know your 9s very well, you see that 9 can go into both 27 and 54. They also both have an S in common. So I'm going to go ahead and take out 9s. What times 9s gives me 27s? Well, that's 3, because 9 times 3 is 27, and 9s times 3 is 27s. And 9 times 6 gives me 54. Did I say that right? 9 times 6 gives me 54, but 9s times 6t gives me 54st. What you need to realize is that when we take the s out of the equation, you will no longer have it underneath these numbers because we've already taken it out. We found that they had that in common, and we took it out. Okay? But when you multiply it back, you still have to multiply it by the number down here to get the original numbers you started with. Okay? So we're going to add another tier to our cake here. And we see that 3 can go into both 3 and 6. So I'm going to take out 3 as well. 3 goes into 3 one time, and 3 goes into 6t 2t times. 3 times 2t gives me 6t. Okay? All right, and I'm going to do one more. But I see that in the end, I cannot take anything else out of 1 and 2t. Only 1. That's the only other number that will come out of both of them. If you want to multiply back, 1 times 1 gives us 1, and 1 times 2t gives us 2t. Whenever you have 2 down here that are the same, you know you're finished. You know when you've only taken 1 out, you're done. Now we need to multiply these numbers on the left-hand side together to get our GCF. 9s times 3 times 1. Well, 9s times 3 gives me 27s, and 27s times 1 gives me 27s. So that is my GCF for 27s and 54st. I feel like I should box it off a little more. Okay, we've got 18 CD and 30 CD. Okay, well, automatically I see that they both have CD in common. And I see that they're both even numbers, so I know they have 2 in common. So I'm going to go ahead and take out 2 CD. Well, what times 2 CD gives me 18 CD? That's 9. 2 CD times 9 gives me 18 CD. And 2 CD times 15 gives me 30, so 2 CD times 15 gives me 30 CD. Now I see that 9 and 15 have a number in common, and that number is 3. 3 goes into 9, and it goes into 15. 3 goes into 9 3 times, and 3 goes into 15 5 times. And now this is my last one because the only thing that 3 and 5 have in common is 1. 1 times 3 is 3, and 1 times 5 is 5. So now I need to multiply these together. Okay, and I've got 2 CD times 3 times 1. 2 CD times 3 gives me 6 CD, and 6 CD times 1 gives me 6 CD. So that is my GCF here. Now, the reason I'm doing it this way, it seems kind of weird, especially if you haven't done the birthday cake method before, and I certainly know that your parents have never used anything like this before, so they're going to be looking at your homework going, what is this Looney Tunes you've got going on here? Okay, but there is a method to my madness, okay? There's a reason why we are doing that. Sorry, my mom's texting me. So there's a reason why we are doing that, and it's because eventually we may need to undo a distributive property, okay, or factor out a distributive property. And when we do that, we can take out our GCF, and what is left are the 2 numbers in the middle. For example, we could turn this into a distributive property by putting parentheses around these, putting a plus sign in the middle, and 6 CD will be on the outside. So 6 CD outside of 3 plus 5, when you multiply those together, 6 CD times 3 gives me 18 CD, and 6 CD times 5 gives me 30 CD. So it gave me 2 of those answers, okay? So Anyways, there is a method to my madness, and you will use it down the road. Okay. All right, so we got a couple more problems to do. All right, we've got 60 JK. No, but seriously. Got it. 45 JK, but seriously. M. All right, so we are going to take out what they have in common. We know for a fact that JK goes into both of them. I can see already that 5 can go into both of them, and that might be the easiest one for you guys to start out with. If you can see that 15 goes into both of them, you could start with 15, but for most of you, starting with 5 is going to be fine. So we know that 5 can go into 60 and 5 goes into 45. So I'm going to take out 5 JK, and 5 JK times 12 gives me 60 JK, and 5 JK times 9 M gives me 45 JKM. I'm going to do another birthday cake tier. And 12 and 9M have 3 in common. 3 times 4 gives me 12, and 3 times 3M gives me 9M. And my last one, the only thing that these two have in common is 1. 1 times 4 is 4. 1 times 3M is 3M. Now I take my numbers off to the left and I multiply them all together. And 5JK times 3 times 1 gives me 15JK. That's my GCF. My greatest common factor of 60JK and 45JKM is 15JK. All right, last problem. Whoop, whoop. Okay, so we've got 36x plus 24. Okay, here's what I was talking about. Look at this. Okay, we are factoring this expression, meaning we are undoing the distributive property. We are taking the number out, okay? So you've got 36x plus 24. We're going to do the same thing we've been doing, the birthday cake method, okay? I know that 2 goes into both of these. Some of you know that 4 goes into both of these, and some of you know that 12 even goes into both of these. So whatever is easiest for you to start with, you can. Since now I've said it, we know that 12 goes into both of those. This one does not have a variable, so we're just going to take out 12. 12 times 3x gives me 36x, and 12 times 2 gives me 24. Okay, so I'm going to put my plus sign there. All right, and the only other thing that we can take out is 1. 1 times 3x is 3x, and 1 times 2 is 2. Okay, you see that when we have the addition sign between them, I continue to bring it down. That's important, okay? The left side, I'm going to then multiply these numbers together. 12 times 1 is 12. So my greatest common factor is 12. And in my parentheses, I'm going to have my 3x plus 2. Okay? So I did the birthday cake method. I found what they had in common, their greatest common factor. I took it out. That's the number on the outside of the parentheses, and the numbers on the inside of the parentheses are what you end up with at the end of your birthday cake method. Okay? I know that's a little weird. I know it's a little different, but the more we practice it, the better we'll get. Okay? I hope you guys have a great night, and I'll see you tomorrow.